Hi, my name's Aloho, and I'm a graduate of MIT. This video will work on some problems to help you further understand chemical bonding. Our first question reads, what type of bond is joining the two hydrogen atoms? A covalent bond, B, hydrogen bond, C, ionic bond, D, hydrophobic bond, or E, hydrophilic bond. Before we jump into choosing an answer, we can eliminate two answer choices right off the bat, and that's hydrophobic and hydrophilic. Hydrophobic and hydrophilic are not types of bonds at all. They're types of interactions. So they're types of interactions that two different molecules or two different atoms on two different molecules can have between each other, not necessarily forming a bond. So for example, atoms that are able to hydrogen bond are considered hydrophilic because that means that they can mix with water, whereas those that can't hydrogen bond are considered hydrophobic. So that's interactions, not bonds. So we've narrowed our answer choices down to A, B, and C, covalent, hydrogen, or ionic bonds. Let's think about the key characteristics of each of the three bonds we have left. Starting with covalent bonds. So for my concept video, we learned that covalent bonds share a pair of valence electrons. So we have two atoms sharing a pair of valence electrons. Hydrogen bond is sort of like a covalent bond, but it has to do with a hydrogen atom being covalently bonded to an electronegative atom. An example of this is in the water molecule. So what results is a partial positive charge on hydrogen and a partial negative charge on the electronegative atom, oxygen, in the example of the water molecule. And finally, we have our ionic bond. Ionic bond is formed when the electronegativity of two atoms are the difference between the two electronegativities are so different that the more electronegative atom pretty much strips the electrons away from the other atom, causing both atoms to become ions, one being positively charged and the other being negatively charged. So now that we've got our definitions down, looking at our image of this bond between two hydrogen atoms, which one makes most sense? The one that makes most sense is our covalent bond. Here we have the two hydrogen atoms, and we have 1 and 2 electrons that are being shared. These are the valence electrons that are being shared by both hydrogen atoms, which is the definition of a covalent bond. So our answer is A. The two hydrogen bonds are joined together by a covalent bond. Our second question reads, this atom, carbon, can form up to blank single covalent bonds. A, 0, B, 1, C, 2, D, 3, or E, 4. So first off, on our carbon atom, we have 1, 2, 3, 4 valence electrons. And in a covalent bond, we have two atoms sharing a pair of valence electrons. So because carbon has 4 valence electrons available, that means it can make 4 bonds. It can form 4 single covalent bonds. This is a very important characteristic of carbon, which is why it plays such an important role in biology and especially in the study of life. So our answer is E. This atom, carbon, can form up to 4 single covalent bonds due to its 4 valence electrons. 4 unpaired valence electrons. 3 reads, the brackets are indicating a blank bond, referring to these brackets right here. A, ionic, B, polar covalent, C, single nonpolar covalent, D, hydrophobic, or E, hydrogen. So we already went over most of our definitions from problem number 1. And again, we can immediately cross off D, hydrophobic, because that's an interaction, not a bond. And so when we think about the definitions that we discussed, which one makes most sense? So our covalent bonds, which are B, C, and E, are bonds where valence electrons are shared equally. Or in the cases of the hydrogen bond, unequally, because there is a more electronegative atom. So when we look at this bond that we're analyzing, it looks like we have partial charges. We seem to have a delta plus, which is a partial positive charge, and a delta minus, a partial negative charge. That's kind of holding these two bonds together. So it doesn't look like they're sharing. It looks like one atom pulled the electron pair away from the other, causing it to become more negative and leaving the other atom to be more positive. And that is a definition of an ionic bond. So what we're working with here is an ionic bond, which is what what's going on in this bracket here indicates. Whereas our polar covalent, single nonpolar covalent, and hydrogen bonds are bonds where the valence electrons are shared, whether equally or unequally. Our ionic bond pretty much rips the electrons away from one and gives it to the other. So our answer is A.